Welcome to The Explainer. Today, we're diving into one of the most important quality checks in all of construction, the concrete slump test. It's this surprisingly simple, on-the-spot procedure that tells you so much about the strength and safety of a building before a single wall even goes up.
You know, when you see a concrete mixer pouring out that familiar gray sludge, it all kind of looks the same, right? But what you can't see, well, that could be the difference between a rock-solid foundation and a total structural failure just waiting to happen. So how does an engineer know, right there on site, if the concrete they just got is actually any good?
Well, that question is exactly why the slump test was invented. It's not about checking the color or the texture. No, it's about measuring a very specific and absolutely critical property of that fresh concrete mix. We're talking about its workability.
Workability. That is the magic word here. This one term basically describes how easily the concrete can be put in place and compacted without falling apart. See, a mix with good workability is easy to handle, it settles properly, and you know there aren't any hidden air pockets. But a mix with bad workability, oh, that can lead to weak, porous concrete that'll crack under pressure.
Now, before we get into the how-to, it's really important to know when this test isn't the right tool for the job. The slump test isn't for everything. It's not great for super specialized mixes like foam concrete or mixes that don't have any fine aggregates or ones using really big aggregates over 40 millimeters. For most standard concrete, though, this is absolutely the go-to test. So, what do you need to perform this crucial test? Well, the beauty of it is in its simplicity. You don't need some high-tech lab or fancy computers. You just need two very specific, standardized pieces of gear that you can use right there on the dirt of a construction site. First up is the star of the show, the piece of equipment that actually gives the test its name, the slump cone. It's basically a hollowed-out cone with the top chopped off. The technical term is a frustrum, and it usually has a couple of handles.
And the precision here is absolutely key. Look at these numbers. The cone has to be exactly 300 millimeters tall, with a 100 millimeter opening at the top and a 200 millimeter opening at the bottom. Even the thickness of the metal is specified. These aren't just random numbers. This level of standardization is what ensures a test in Mumbai gives you the exact same results as a test in Miami.
The second piece of your essential kit is the tamping rod. This is what you're going to use to compact the concrete inside the cone. You've got to get rid of any trapped air to make sure you have a uniform sample. And yep, you guessed it. That same intense need for standardization applies to the rod. It's got to be 600 millimeters long with a diameter of 16 millimeters, and the tolerance for error is tiny. It's this incredible attention to detail that makes the whole test so reliable, anywhere in the world. Okay, so you've got your cone, you've got your rod. Now let's see how it all comes together in a simple procedure that, believe it or not, has to be done against the clock.
You have exactly 3 minutes, 180 seconds. That is the time limit, according to the official Indian Standard Code, from the moment you start filling that cone to the moment you lift it off to get your result. It's fast, it's efficient, and it has to be done right.
All right, here's the core procedure. First, you put the cone on a flat, non-absorbent base. Then, you fill it up in 3 equal layers. And for each and every layer, you have to tamp it or poke it precisely 25 times. Once it's full, you scrape off the top to make it perfectly level. And finally, you lift the cone straight up, nice and smooth, over about 4 to 5 seconds.
But the crucial thing here isn't just poking the concrete 25 times. It's all about the technique. You use a freehand motion, just letting the rod's own weight do the work. You spread those 25 tamps out evenly. And with each new layer, the rod has to just barely penetrate the one below it to kind of stitch them together. But there is one critical rule. You must never hit the base plate.
This right here is the #1 rookie mistake. If your tamping rod smacks that base plate, it can vibrate the cone just enough to let the watery cement paste, the slurry, leak out from the bottom. And the second that happens, you've changed the water content of your sample, and the whole test is useless. You have to start over.
Okay, so the cone is off. The concrete will now slump down under its own weight, and the shape it holds, or fails to hold, tells you everything you need to know about the quality of that mix. There are really 3 main types of slumps you're looking for. First, the result you're really hoping for, a true slump. This is where the concrete cone just kind of sinks down evenly, holding its shape for the most part. This tells you it's a good, cohesive mix. It's got the right amount of water, it's perfectly workable. That's a pass.
Next, you might get something called a shear slump. This is where one side of the cone just shears off and slides down. This is a warning sign. It suggests the mix doesn't have enough cohesion. Maybe the aggregate mix is off, or it's a little too dry. If you see this, you need to do the test again.
And finally, the big one, the collapse slump. This is a definitive, no questions asked fail. The moment you lift that cone, the concrete just completely collapses into a flat puddle. This almost always means one thing. The water-to-cement ratio is way too high. The mix is too wet, it's unworkable, and it will never reach the strength it's supposed to.
But it's not just about the shape, it's also about the measurement. After you get that cone off, you take your tamping rod, lay it across the top of the cone, and measure the distance from the bottom of the rod to the top of the slumped concrete. That number, in millimeters, is your slump value.
So what do these numbers actually mean? Well, every project has its own specific needs, but a typical sweet spot for good, workable concrete is a slump somewhere between 90 and 120 millimeters. Now, if the mix has to be pumped through long hoses, a slightly higher, wetter slump might be okay. But anything outside the project's specified range is an automatic red flag.
So there you have it. In just a few minutes, with some very simple equipment, an engineer can figure out if a whole truckload of concrete is safe or a massive liability. But this brings up a final, really important question. What happens when it fails? The logistical headaches, the financial stakes, they're huge, and it's a decision engineers have to make on construction sites every single day. Thanks for joining us on The Explainer.